So in part 2 of section 2.2, let's talk more about symmetry. So symmetry is when in algebra, when you can fold across an axis or a line and have the object fold onto itself. So the parabola we saw in the last segment was definitely symmetrical about the y-axis. So let's talk about the 3 types of symmetry. So we can have symmetry to the x-axis, the y-axis, or the origin. So symmetry to the x-axis basically means that we can fold this across the x-axis and it would fold right on top of itself. So the x-axis is the fold line of the paper and it folds on top of itself. What it means in terms of the picture is if I pick a specific value for x and I follow it up to the graph, I'm going to have a corresponding positive y value and a corresponding negative y value. So in other words, on this particular picture, you have x with a negative y, and you also have the same x, but with a positive y. And that's why it folds across the axis in that direction. In terms of the y-axis, here's that parabola again. It folds, the y-axis is the fold line, so it's folding across that y-axis. For this picture, what we're going to see is that if we pick a particular y value, we're going to have an x on the left side, and we'll also have an x on the right side. So for this one, we would have a positive x along with that negative y. And over here, we would have a negative x with that negative y. So you'll notice that the sign changes on the x's because it's folding across the y-axis. The third type of symmetry is across the origin. What this means is it's kind of a double fold. You can fold it across x and then y, or vice versa, your choice really. But yeah, if I take this half, I fold it over here and then fold it up, sure enough, it's going to fold onto itself. So when we talk about points over here, if I have a point at x comma y, then there's another point over here that is at negative x and negative y. Both the x and y have had a sign change to see that symmetry. And those are our 3 types of symmetry. It's easy to do when you look at a picture, but how do you do it if you're given an equation and you're not graphing the equation? So that's our example 3. Example 3 asks us to list the intercepts, some more practice at finding intercepts, and then test for symmetry. So testing for symmetry is what we're focusing on here. So there are 3 examples there. So example A, the equation is y squared equals x plus 9. So let's walk through what we were doing before in the previous part, finding those intercepts. So let's go find the x-intercept. To find the x-intercept, we're going to let y equal 0. So then 0 squared would be equal to x plus 9. So x is equal to a negative 9. So the x-intercept is at negative 9, comma 0. To get the y-intercept, we're going to let x equal 0. So y squared would be equal to 9. So then y is equal to plus or minus 3. So I have 2 intercepts here. I have 0, comma positive 3, and I have 0, comma negative 3. And that right there kind of gives us an insight. If we have two y intercepts, right, then maybe this thing is going to fold across the x-axis. But we need to test it to be on the safe side. So here comes our test. We didn't write these down before, but they come off those pictures we just drew. So let's do the test for symmetry. So for the x-axis, what we're going to do is replace y with negative y in the equation. Okay. If there's no change, then you have symmetry. So the equation does not change. We have symmetry. And let's make sure that makes sense to us in our brain. So in other words, if I come in and take y and replace it with a negative y, positive y with a negative y, and there's no change in the equation, that means that it can fold across that x-axis and have symmetry to the x-axis. So we're going to take our equation, which was y squared. So here's the original, is equal to x plus 9. This is the original. We're going to come in and take that y and put a negative y in its spot. So here's the test. We just need to clean that up. Well, a negative y squared is just y squared. And when I compare this to the original, they are the same. There is no change in that equation, which means yes, indeed, we have symmetry. So yes, symmetry to x-axis, which kind of backs up what we were thinking over here when we got the 2 y-intercepts, is that we had symmetry to the x-axis. So again, it's just like finding the intersection, replace the opposite letter. And now let's go see if we have symmetry to the y-axis. Okay, so basically, all that's going to change for symmetry to the y-axis to test is now we're going to replace x with a negative x. So that's easy for me to write down because all I have to do is erase and write it in the equation. If the equation does not change, we have symmetry. So again, replace x with a negative x in the equation. If the equation does not change, we have symmetry. Okay, so that means that we're going to have y squared equals x plus 9. Again, this is the original. And I'm going to come in and replace that. Here's my test. We're going to replace that x with a negative x. So that would give me y squared equals negative x plus 9. Well, that's not the same. So it is changed. So that means there's no symmetry to the y-axis, which we kind of already guessed because we just got a single x-intercept. We didn't get a pair of them. So this thing is not going to fold across the y-axis. And that's symmetry to the y-axis. Again, replacing the opposite letter to test for it. Then we have the origin. So now we're going to come in and test for symmetry with the origin. So to test for symmetry to the origin, what you're going to do this time is we're going to replace x, negative x, and y with negative y. No change equation. Yeah. Because we need to be able to fold both across the y-axis and also across the x-axis. You're looking for both things. So I have to replace both of them, and we don't want any change in our equation. So for us, we're going to come in again. The original equation was y squared equals x plus 9. This is the original. We're going to come in and replace that y with a negative y, and then x with a negative x. And I can do it all in one line. Well, we know that this doesn't change. The negative being squared is positive. But we do have a change on the sign on the x. So our equation is not the same as our original because that negative on the x. So not the same. So no symmetry to the origin. So we worked an example as we explained the symmetry. Now we come and do an example without having to write down the steps and see if it makes sense. So this is part B on example 3. Okay, part B says that y is equal to x to the third minus 27. So let's go find the intercepts first, and then we'll come in and test for symmetry. So by now, hopefully you're getting used to the intercepts. To do the x-intercept, we're going to let y equals 0. We'll get x cubed minus 27 is equal to 0. So 27 is equal to x cubed. X is the cubed root of 27. We cubed root both sides. So x is equal to 3. And again, you only add the plus or minus if you're doing even roots, not odd roots. So we end up with an x-intercept at 3, 0. A y-intercept, we're going to come in and replace x with 0. So we have 0 minus 27. That's a negative 27. That is way down there. So that's 0, negative 27. Okay, now notice no repeats, right? We don't have a plus or minus anywhere. So we're probably thinking that there's not much in the way of symmetry here. Okay, let's come in and test for. We have to do each one of them. So let's do the x-axis first. So because we're testing for the x-axis, we're going to replace the opposite variable, that's the y, with the negative. So that would be negative y. And remember, sorry, let me write down the original so I can compare it each time. Here's test 4, and here's our original. Y equals x to the third minus 27. So that would be negative y is equal to x to the third minus 27. So all I did is replace the y with the negative y. And when I do this, you'll notice that all of a sudden that it's not the same. So not the same. So it has changed. Sorry, as I put stuff on the floor, changed. So that means no symmetry. So this equation does not have symmetry to the x-axis. Let's go look at the y-axis. So now we're going to replace an x with a negative x. So I'm going to take that negative x, I'm going to cube it. Well, when I cube a negative, it remains negative. And when I compare that to the original, the sign on the x has changed. It is not the same. Change, so no symmetry. So we do not have symmetry to the y-axis either, which backs up the intercepts over here that we already discovered. Okay, what about the origin? The origin can be kind of sneaky. So we're going to replace the y with a negative y. We're going to replace the x with a negative x. So I have negative y equals negative x cubed minus 27. Now I'm always a little suspicious when I have that negative on the left side. So I can go ahead and algebraically rearrange things. So what we're going to do is we're going to come in and multiply everything by -1 or divide out the -1. And that's going to get rid of this negative over here. Now, if I do that, and you're thinking, well, why would I do that? Well, I just want to make sure it is not the same. If I divide out the -1, that's going to make that x cubed a positive. But it is going to change the sign on the 27. So when I compare this to the original, it still is not the same. So not the same. That's changed. No symmetry. So this particular graph has no symmetry to the x-axis or the y-axis or the origin. It doesn't have any symmetry at all. So, which is helpful when you go to solve it. It gives you an idea of how many points you have to plot. They'll use the idea of symmetry. We will use the idea of symmetry again when we talk about even and odd functions. And then you extend the idea of even and odd functions into trigonometry when you're taking the pre-calculus class. So, okay, in part B or C on example 3 gives us another equation. So y equals x squared minus 4 all over 2x. Again, the directions are still asking us to list the intercepts and test for symmetry. So let's go list our intercepts. Let's go find them. Let's go find the x-intercept. And that replaces y with 0. So 0 equals x squared minus 4 all over 2x. We need to solve this. We didn't do a lot of these yet, but we can solve a fraction. So we're going to come in and multiply everything by the common denominator, which is 2x. 2x times 0 is 0. That's just going to give me x squared minus 4. So x squared equals 4, and then x is equal to plus or minus 2. So we're starting to think about how that's impacting our symmetry. So we have a positive 2, 0, and a negative 2, 0. To get the y-intercept, we're going to come in and replace x with 0. So y would be equal to 0 squared minus 4 over 2 times 0. We're running into trouble here because we can't divide by 0. So that's okay. This is undefined. And again, it's okay for that to happen. So what that simply means is that there is no y-intercept. Don't have to cross the y-axis, and this one does not. So we have x-intercepts at positive 2 and negative 2, and no y-intercept. So that's really impact our symmetry idea. Okay, let's come in and test for symmetry. So we're going to come in and do our test. Let's do the x-axis first. And again, here is our original equation. So this is what we're going to compare to. So we replace y with a negative 1. So that would be negative y is equal to x squared minus 4 over 2x. That is not the same. Not the same, which means no symmetry to the x-axis. Let's do the y. So for the y-axis, again, you're replacing the opposite variable. So that would be y is equal to a negative x being squared minus 4 all over 2 times negative x. So y would be equal to x squared minus 4 over negative 2x. It's okay to bring that negative up, sorry, not the 2, which is the negative, and write it on the bar. So y is equal to a negative of x squared minus 4 over 2x. So when I compare that to the original, it is definitely not the same. We have changed the sign on the right side. So we don't have any symmetry here either. So not same. No symmetry to y. Wait a minute. We had this going on over here. Why are we not getting something out of this, right? my X, I had two X-intercepts. Why is this not folding across that Y-axis? Well, let's go test the origin and see what happens there. So for the origin, we replace both. So we know it's a negative Y on this side. And on this side, when we replace the negative X, the end result was this. So I'm kind of skipping a few steps because we've already done the grunt work in the previous example. We know that the end result, once I clean up the negative X, was this. This time, when we divide out that negative 1, we get Y equals X squared minus 4 all over 2X. And that is the same as the original. So because we can do that dividing out the negative 1, we get the same original equation back. So this thing has symmetry to the origin, which is why we were getting that repeated X-intercept over here, is because that symmetry is to the origin. So, not exactly what we thought would happen, but we can definitely understand what did happen.